من حقیقتا دارم تست میکنم ببینم که این از کجا لایو ست کرده محمود. هنوز موفق نشدم. اول به من یه دونه لینک یوتیوب داد، بعد عوض کرد، نمیدونم ری استریم داد، الان نمیدونم کدومه. آره الان دیدمش. خب خب بچه های خورده لایومون قاطی شده. من الان نمیدونم صدا خودم از کجا دارم. چقدر عجیبه. خب به نظرم اوکی. اوکی. خب دوستان خوش اومدید به این جلسه از لایو برنامه نویسی گومون. فقط نکته بگم که این پروژه رو داریم همینجوری فعل بداهه میزنیم. من فقط یه خورده اون کتابخونه وب ساکتی که قرار استفاده کنیم یه خورده باش بازی کردم. حقیقتا کلش رو میخوایم فعل بداهه بزنیم و تروتی قطعا زیاد داریم. من کل اسکرینم هم همش رو شیر کردم که اگر سرچی میکنم جایی چیزی رو میبینم که شما ببینید و در جریانش باشید. و اینکه یه نظرسنجی هم توی توییتر گذاشته بودیم که انگلیسی بریم این لایومون رو یا فارسی بریم، که انگلیسی رای آورد. سعی میکنیم انگلیسی بریم. از این بعد میخوام سویچ کنم به انگلیسی. Okay, hello everyone and welcome to this live coding session. I will be coding a WebSocket chat server and we will be going through the code together. Okay, let's start. First, let me talk about the WebSocket and how actually the connection for a WebSocket connection is created. When a user wants to connect to a WebSocket server, we usually start with a HTTP connection and then upgrade from it to a WebSocket connection. So basically, WebSocket sits on top of the HTTP, and that's the basic of it. So I will be starting with the main Go file, and this will be the skeleton of our project. So, coming from PHP. Okay, let's go through this WebSocket library. I have Ali with me here. He's helping with the live session, and he's asking why he's just seeing me. There's a delay between. There's a 10 seconds delay. Good point. I'm just showing myself. I think it's okay now. Okay. We will be using this WebSocket library. There is a better, well-known WebSocket library which is part of the Gorilla toolkit. I have some experience using that. I developed a project a few years ago with that library, but I'm going to use this other package, which is a little less known, but I think it suits our need, and just for the sake of it, I'm going to use this new one. Okay, this is a really simple library. We just start with a HTTP server, and then we create a handle function which accepts a request, and then here we see this accept method here that upgrades the connection from HTTP to WebSocket, and the connection is established. So we will be using this example here, chat. It says chat, but it's a very simple, it's really basic example. So we will be adding a lot of features to it, and let's see what we can achieve in this 1 hour and a half session. Okay, let's start with another file, which will be our server. I will be writing all the code inside a single package, but we will try to adhere to standards such as solid and using interfaces so that we can easily decompose the project into smaller packages at a later time. But for now, we will be sticking to main. We will have a WS server structure. Going to look at this example here. Let's close this tab. Okay, this is pretty straightforward. There will be a function serve what was it called? Let's get a little help here. Serve HTTP accepts a HTTP response writer and a HTTP request. And here we have an error here. Okay, good. So here we will be starting from a HTTP server. This is a simple one. We will begin with a net listen. Yeah, we will be using TCP, and the port is going to be, for example, 8000. Okay, we have a listen, and let's panic in case there is an error here. And there will be a HTTP server. Okay, so we have a handler here, which we are going to use our own WebSocket server here. Undeclared name. So what's wrong? Let's check the example here. HTTP server, handler, everything is okay. And new server returns a chat server here, which must have a serve HTTP function. And yeah, that should be it. I think we are doing this wrong here. So, undeclared name. Why the fuck is it doing this wrong? I think VS Code is toying with us. HTTP declared but not used. Listener not used. I'm going to. Okay, this is not a good start. Does not recognize my WS server. Okay, I'm going to here. Okay. handler should be a handler. This is an interface which is has a server HTTP function. Not seeing anything wrong with it. Okay, cannot use the servers. Missing method server HTTP. Okay, this is better. It's recognizing my WS server as a server HTTP response writer and a request. Mahmoud is here. Cannot use WS server. Okay.
Would you increase the font size? Would you increase the font size?
Okay. Let's see if we can increase the font size here. Is this better? So let's go back to our struct here. Okay, cannot use WS server variable of type a pointer to HTTP server as HTTP handler value in struct. I'm doing this wrong because this is not HTTP server. This is a WS server which moves us back to the first square because it does not recognize this one. So let's see what's wrong with this. Do we have this type WS server? I'm going to reload VS Code. See if, okay, yeah, that's better. Everybody says don't use VS Code, but I'm always sticking to it. Okay, let's start with L, which is a listener, and it's here. And let's see this one, if it returns an error. We have already an error defined, so okay, we got off to a tough start, but I hope the rest of it goes smoothly. So we have this HTTP request here. We will be having just the one endpoint, and if you look at here inside the example, we have multiple different endpoints for subscribe and publish, but we are going to serve everything in a single endpoint because we have a real-time chat server. Everybody is going to connect to it and then receive and then publish and receive messages at the same time. So everything will be served under the same path. Okay. I'm going to copy this from here. And we will be using this package name here. Another import. One thing I forgot to do before starting the project is to initiate the Go modules here so that it can easily distinguish between packages and load it. I'm going to name it Go for conf WS chat. Okay, Go mod tidy. Okay, everything is in order, and I'm going to remove this. I'm going to panic for now so that we can focus on what we're going to do right now, and then do everything, do the pretty things later. So we have this WebSocket connection here. If you look at inside this code, you see that we are accepting an HTTP request and doing this upgrade thing here, and this is pretty much all there is to it, to upgrading a connection from HTTP to WebSocket. So what we will be having here is a WebSocket connection. Okay, I'm going to leave it at that and start. Let's rename this here so that it doesn't throw an error. Okay, we have a client connecting to our WebSocket server. What should we do about it? Okay, let's create a client. Every user connecting to our server is going to be a client, and every client will be having a exclusive WebSocket connection for themselves. And let's define some useful functions for this client, much like write message, which is going to write a message to the WebSocket, and we will be accepting a context. I am personally trying to go into the habit of using context everywhere, so why not start here? We will be having a message body, which is a byte array, and then let's return our error for now. Okay, seems good. Turn nil here. I'm going to explain the idea behind this function in a bit. Okay, we will be writing to the connection. It has a write method, which is going to require a context. Convenient. And a message type, which is going to be message text. We have a message binary and message text. We can actually send files using via the WebSocket connection, but that's not the topic of this session, so I will be ignoring that. And then the body of the message, which we have here. Okay, and then what it returns here is an error. Let's just return that. So inside this server function, I'm going to create a client for every incoming WebSocket connection, not HTTP client, just our own client, and we will be assigning the new connection to this client in here. Okay, so where do we hold on to this client? I'm going to create another entity inside this system. This entity is going to be responsible for collecting all the clients and having a reference to them. And basically, this is a coordinator which we will be fetching clients based on the target of an incoming message. So I'm going to call it what should we call it? Manager. First package. This is instruct, and okay. What this manager should have is a list of all the connected clients. So I will be having a, let's say that we have a map of them so that we can easily look them up. And let's just say that it will be a map of few unsigned integers to references of clients. And I used integer here because we will be having a map of clients based on their IDs. And let's say that we have an ID here, which is again uint64, and yep, this is it. Again, a couple of utility functions in this. Add client, context, and then the client itself. And it's going to return an error just in case. Let's put some nil here. This is just a map allocation. So m clients ID will be our client, and there will be no error. It doesn't make any sense to return an error here, but we are going to leave it here. So maybe later we have another implementation of this manager which is going to hold the clients somewhere else, which upon adding, maybe it will return an error. Okay, we have the client here. And for now, I'm going to have the manager as a property of this WebSocket server. And manager. So, yes, that manager that add client, and yeah, it needs a context. Let's create a context. No, second thoughts, it doesn't need to be a deadline context or anything, just context background is enough for now, and the client, actually the reference to it. So we have our clients added to our manager. Okay, let's use this all in here. I'm going to run this project for the first time. Let us print on. There's in here. Let's run this project and see if it's okay. Cool. There's no error. Before connecting using a client to the server, I'm going to print some messages so that we know we have some incoming messages or connection requests, etc. Let us say here, new request for connection. These messages are just for the sake of example, and we can remove them later. And okay, I'm just going to show you this is indeed happening. Okay, client added. I'll run this again. So we have our WebSocket server listening on port 8000. I'm going to connect to it. I will be using this beautiful WebSocket client, which is called WebSocket. I shared the link in Twitter with everyone if you're interested. And our server is running on localhost port 8000. Okay, let's see the log. Okay, there's a panic. Invalid memory address, no pointer to reference. Okay, we haven't initiated this map here, so let us go back a little bit. Okay, this is a manager, which is going to be a reference to a manager, and the clients inside is a map. So we will be using the make function, right? There's an S missing there. Okay, let's do this again. Oh, hooray! We have our client added, and here we go. So, up until now, we've just added the clients, and the client is not listening for incoming messages, and there's no way for us to actually send a message to it. So right now, what I will be doing is making the client able to listen for incoming messages from the WebSocket. I'm going to make this function. What did I say? Function. What is that word? Start accepting messages. Okay. There will be a context and error. Return a nil here. Okay, so we have this function here on this connection that reads a single message from the pipeline and then returns the body of it. So for this to work, we need to use this inside loop. There are some messages, I think. Not important. Let's have this for loop. So we have this context, so let's use this. We're going to use a select and a case ctx for when the down channel of this context must be send or receive. Yeah, which is right. So let's just print a message here. Done listening for messages, and then return. Okay, what else? We have this default here. There's not. What is this? Wrong number. Okay. Says that we need an error. So here in this default branch, we are going to read the message. Client, which is a C, can, and then read. We will be just passing this context down the call chain. So we have this read function which returns a message type, a byte array, and an error. I'm going to capture all the values here. Irrelevant. In case there is an error, return from this function that same error. And I'm going to ignore this type here because we are just going to work with text messages, and then we have this body inside this variable. So okay, we have this body, so what should we do with this? I'm going to just for now assume that we are using JSON as our transport protocol. So there will be a map string interface here, which is our message data. I'm going to use JSON unmarshal here, and if there is an error, let's just return it back. Okay, where did that go? Why did I close it? So we have this data here and nothing to do with it. Okay, let's have a contract with ourselves. Whenever a client connects to our web server, they should introduce themselves. By what? By assigning themselves an ID. So we can easily fetch them from this map here by their ID, and then so that we can easily send messages to them. And I'm going to do this right here. Another function for client. Some might argue that this is not the right place, but let's just do this. Wait for register. And it is going to be a context and then an error. And nil here. We're going to need a reference to the manager. I'm using Vim mode, so forgive me these mistakes. I'm going to accept a reference to our manager so that we can add this client to the map. And okay, let's just do this. Another for loop. Just going to copy this from here. There we go. I'm going to use yank it and then paste. Okay. Done listening. Let's change this message to register, and then this and this and this, and we're going to read the message here and going to use the ID index, and I'm going to cast it to int 64. Actually, not int 64, because everything inside of JSON is converted back to float 64 if it's an integer. And then I'm going to cast it here. Okay, and this is our ID here, and I'm going to assign this ID to this client right here, and then we have our manager so that we can insert ourselves inside the map. Okay, and see, this looks good. I'm going to, okay, so what we need to do here is skip this part because we don't want to add a undefined client to our manager because it doesn't have an ID. So instead we will be using the wait for register here. Instead of using the background context, I'm going to set a deadline for it so that we don't wait for a client to introduce itself forever. We're going to use a context with timeout, and yeah, a duration and a parent. I'm going to use background as parent here, and then let's wait for 60 seconds. If inside this 60 seconds a client fails to introduce themselves, we will just throw them away and the garbage collector can collect it and get rid of it so that we don't have a memory leak. Okay, and context, and we are going to pass a reference to our manager, and then we have this cancel function, which is I'm going to ignore for now. So we are waiting for a register, and then okay, this is an reachable code. Just going to do this. This is actually wrong. You know why? Because if we call this function, it's going to enter this endless for, and it's going to lock forever, and it's basically a deadlock. So what we need to do is put this inside a dedicated go routine. This is it. So we will be using the return nil again, and we don't want to return anything here. Okay, I'm just going to panic for now. This isn't right, just don't do this. But for the sake of brevity, I'm going to use the panic here. Okay, and we are good to go. Done, and clients added. I'm going to just print the ID here so that we see it. Let's just use print ln instead of printf, and yep, I think we are good to go. So what happens here is that we wait for the client to introduce himself by their ID, and when they have sent us their IDs, we will be adding them to the manager, and if not, we will be throwing them away because can't wait forever for a client to introduce themselves. So I'm going to run this again. Let's see what happens. Okay, no error, good. Okay, new request for connection. Everything seems to be okay, and we will be using JSON here. I'm going to say that my ID is 3456 and send. Hooray, we have this client here. Just for the sake of it, let's have another client. Okay. So that we see we can have many number of clients connecting to the I fucked it up. Error running because you have an error because when we sent that invalid JSON message in here, we wanted to unmarshal it and it panicked. Okay, instead of a panic, we can just ignore an invalid message and just retry waiting for a new one. So I'm going to use continue here. Let's just write something so that we know something's wrong. And let's do the same for here. Okay, I'm going to reintroduce both clients. Okay, just another random ID and we are good to go. We have 2 clients connected to our server and they are added to our list. So what now? Okay, if everything goes as planned, we can call start accepting messages here, which is an indefinite action. So I will be using a new context because we don't want to use this context because it has a deadline and we don't want to use it. So I will be starting to listen on for messages here and okay. See this message? Done listening for register. Is because we don't handle this for loop. It's just going to continue again and run forever. So basically, when we are doing this here, we are just going to return and exit this loop so that this function is done and done. Okay. Right here now, I'm going to use another go routine for this, because again it is a indefinite action which is going to wait forever for new messages. So here, and let's continue here. Okay, let's say that we have a new message right now. And let's just print it. I'm going to use that body and just echo it to the screen. Okay. Again, we need to introduce ourselves. Good. And we can just as easily send messages. Okay. We're not seeing anything here, so what's wrong? Let's see what's wrong here. Okay, start accepting here, go and edit, and select. I don't see what is wrong. Okay, I'm just going to ask if anyone has a question up until now. نمیشه لایو رو فارسی بذارید؟ چرا میشه، ولی خب گفتیم که تمرین کنیم، بالاخره زبان انگلیسی رو همه باید یاد بگیرن دیگه. برنامه نویسیم، داریم به زبان انگلیسی کد میزنیم، بهتره که انگلیسی هم بلد باشیم. یکی از دلایل اینه. دلیل دیگه اینه که خودم میخوام تمرین داشته باشم که حالا پرزنتیشن های خارج توی شرکت هم که میذارم به خورده راحت تر صحبت بکنم. So forgive me for this, but no, I can't speak Farsi. Any questions? Nope. Okay, let's go back to our code. What time is it? 17:22. Just been an hour. Okay, let's see what's wrong with this part, that we are not getting any messages here. Okay. We may have done something wrong here, so I'm just going to print the error here and here. Let's try again. Okay, invalid character D, looking for beginning of value. Okay, the problem is obvious. We are waiting for a JSON here, which is not this message. It's pretty obvious. Stupid of me to think that I can't just send any values here. I'm going to go back to JSON. Okay, as you can see, we have our message here. So this is no good as a chat server because we're just printing messages to the screen and it's not delivering messages from one user to the other. So what we should be doing is delivering messages. This is a chat server after all. So we are going to have to add some other things to our convention for messages. We are going to need a target, which is, sorry, the ID of the user which is going to receive this message, and we are going to use U in 64 because that's what we use for IDs, and then we cast this to float 64, and yeah. Okay, so we have our target ID. So I'm going to add another function to the manager. Send message, a context, a target ID, which is an on-site integer, and the message itself, which is going to be in a byte array. Error. Okay. Come on, man. So what we have to do is fetch the right client to send the message to them. And let's just make sure that we actually have that client. This is a syntax which checks if a item actually exists inside a map, and then if it does, the OK will be true. Which is not, I'm going to return an error, undefined, or the target does not exist. Okay. Unfortunately, we have to define client here. Declared but not used. Declared but not used. Come on, go. So we have our client, and we will be using the write message function and the message itself. So, okay, and we will be using that start accepting messages. Okay, we don't have access to a manager, so we're going to require a reference to it. Which is again passed along in this. I avoided using a global variable for the manager because that's not always the best thing to do, but just pass along the value for every function that needs it. And yeah, and open manager, send message to context. Yep. Let's use a timed out context here again. I'm going to use that one, and then if you can't send the message in 10 seconds, just fail. So send message, and we have ctx target and the body of the message as is. Okay, send message, send message. Okay, client what message, and then just that. Let's run it and see what we have done so far. Going to have to reconnect. Going to introduce myself as user 1 and here as user 2. Okay, we have user 1 and 2 added to our manager, and then we are going to send some message. Target is 2 and message is hello. Let's see. Okay, as you can see, we have this message here, safe and sound, and we are seeing that our service is actually working. So, what now? I'm going to add a second feature to the server. What happens when we have a user which is not online at the moment? How are we going to do that? Okay, just before that, is there any question before moving along? No, no question. Either we have no viewers or my presentation is so awesome that doesn't leave much to ponder about. So, okay, we can't use channels here because whenever a user is not connecting, it doesn't have a client and it's not going to have a exclusive channel for their messages. And I'm going to use something called queues here. Okay. Rabbit mq docker image. Going to use the 3 management tag. I want to use RabbitMQ as our message broker, and the reason we are using a message broker is that, as I said, whenever users are offline, we don't have a solid reference for them so that we can store their messages. The best thing to do is just push the message inside a message broker so that we can have them delivered later by just subscribing to that message broker. Okay, I'm going to Docker pull and use RabbitMQ management tag. Let's see how we can run this. Okay, management plugin, and then just going to use this one and then name some Rabbit host name, localhost, run it as a daemon. I'm going to expose some ports and let's see. Okay, this is the port for our AMQP protocol, and I think this is the one for the management, which is mapped to this port. Let's try this. Going to be calling this one, and guest is the default password here. Great. We have our RabbitMQ running in this port, and then we will be using Golang AMQP. This is the best, or let's say most well-known client for the MQP, which is the protocol that RabbitMQ uses. I'm going to be using this. Let's use the examples here. It pops up and this, and okay. This is good. This is good. Subscribe and then going to create another file. RabbitMQ.go. Package name, and going to have a struct for this, RabbitQ struct, and then what we'll be holding on to is an AMQP connection and an MQP channel. Okay, at least it recognizes it. Let's have it fetched. And okay, going to make new RabbitMQ, which accepts context here and then returns a reference to our RabbitMQ struct and an error in case there is an error. Just going to create the connections right here. And this is it. We'll be using this same example. Okay, name URL and okay. This is where it does the connection. Return RabbitMQ and nil here. We have this cannot use URL string. A string value in, what does it say? Sort. So we have an APK-MQP connection here. Connection and then the channel. Okay, and then let's create a channel right here. I believe this is not the right way to handle this channel creation or any part of it, but just for the sake of example, I'm going to keep going on this path and let's see what happens next. Okay, we have our server here. Let's say this. Let's use the ports right here. Okay, and I think the syntax for using and password was this. And okay. So we have our RabbitMQ connection. What we're going to do now is define some functions on this RabbitMQ struct. The first is queue message for a target. Context, as always, it's going to accept a uint64 and then the message body, here, and it's going to return an error. Okay, before publishing any messages, we have to make sure that the queue that we are looking for actually exists. So I'll be declaring the queue. Let's see if I can use memory for this. Queue declare, and I'm going to use sprintf for this user and then $D and I'm going to use a target here. And is it going to be durable? Yes. Is it going to be auto delete? False. Is it exclusive? No. Is it no wait? True. And nil. Okay, I'm just going to catch the queue. Sorry, what? What? Huh? Queue and error here. Okay, if error, return error. It's actually a good practice to wrap this error inside another error. Just we don't have the time for it right now. And we have this queue, which we can use. Okay, count the messages, whatever. Come on. I don't think we actually need this reference to the queue itself. So what we are going to do is use the queue channel again, and okay, I think we had this publish method here, and going to use an empty name. The queue name, the key will be actually the name of this queue, which we've used right here. I'm going to do it again. And is it mandatory? Is it immediate? And yep, the message itself. I actually don't remember what this mandatory thing was. I'm just going to set to false. Is it immediate? No, we don't need to be immediate. And then the AMQP publishing format, which is going to be like this. What did we name it? Message. So I hope this is it. I'm going to return. Okay. Well, we're going to use this inside the manager, of course. It's going to have a reference to our RabbitMQ. And okay, instead of returning error here, now we can use the RabbitMQ to actually queue the message for offline users, in hope that someday they are going to come back online and receive their messages. Okay, context, and I will be using the target here and the message body itself. So what's the error? Undeclared name. Okay, this is target ID, and instead of returning just use here. Returning error, we say that the target user is not online, the message is queued. And we're going to turn nil here. So we have this queue message function here. Let's see if it works. Just before that, we are going to assign a RabbitMQ for this. And where did we do that? We have the manager here, okay. And the queue will be new RabbitMQ. A context is a context background. Okay, can't use it like that. So we'll be using this, and error here, if error panic, and then use the RabbitMQ here. Okay, I believe this is it. Let's run our project again. Go run dot. Okay, let's check our RabbitMQ and see if we have an open connection. Yes, yes, we can see it. Okay, let's do it. WebSocket. I'm going to introduce myself as 1 and the message body as hello. Okay, let's see what happens. Client added. Oh, this was just introduction. The register actually. The message is here. Target will be 2. Message will be hello. Howdy, stranger. Okay. Target user is not 1. The message is queue. Let's see if we have the queue here. Okay, this is beautiful. We have a queue here and a ready message to be delivered. So, what if the user comes back online? Let us handle that someplace else. So, here we have this start accepting messages, and we have to have another go routine for this to work. I'm going to God, I hope I don't sound foolish speaking English like this. Consume messages from broker. Again, you got context, and just like that, it's going to return an error. Okay. So we need again to add some functions for this RabbitMQ. So messages for target. Going to use a context and the target, and we are going to return from this a channel, which is a read-only channel of bytaries, and if anything goes wrong, and an error. Okay. Again, we're going to have to make sure that the queue, actual queue, exists on our Rabbit server so that we can consume from it. If there's no other messages in it, we just wait forever. And okay, queue declare, and just like that, you're going to use the channel again and then consume. Okay. This one returns exclusive, no low card, no wait. Looks good. We will be using the name of our queue, consumer string. I don't believe it was necessary, so I'm going to let's set the auto act to true and then exclusive to false and no local to false and no wait. What do we set for no wait here? One, two, three, four. 1, 2, 3, 4. There's no wait, true. Okay, we're going to use true again here. Actually, here. And then a nil. Guess. So what is it? Nil to bool. Okay. Just put it back to false. Okay, we have our delivery channel and error. Return error and like that. Okay. We are going to do a redirection here because we don't want to expose this channel right here to the outside world. We are just going to have a simple binary channel. We don't want all the unnecessary things that RabbitMQ provides in its deliveries. So I will be using a handmade channel right here, which is going to be a channel of byte arrays, and I'm going to make it an unbuffered channel. This is the one actually we will be using in our clients. And no, okay. And we have our 4, and then we can read from the delivery channel right here. Okay. We will be just writing to this channel the body of our delivery. Okay. If you notice here that we have set the auto ACK for this consumer, so we don't need to manually acknowledge the messages. It just does it automatically. Okay, this is it. Actually, this is going to be a problem here because we are not having a mechanism to cancel this. Okay, let's just put this. Let's not make technical depths for ourselves. I'm going to use select, use the context done channel, right here, and I'm going to return from this, and there will be this here, and yep, just like that. We can use our context to cancel this go routine whenever we are done with this client. Okay. So, what now? Consume messages from Brooke. Here we are. Again, we are going to need a manager for this. And here we have this other go routine, which is going to again listen for the done channel of the context, and again on right here, that's come on, I'm going to have this one, which is here. What was it? Consume messages for target, and the target is ID. Okay, an error right here. If we have an error, let us just return it, and yep, message is a received message. So we have our message from Q, and we basically have to just write it to the socket. Okay, write message. And we're going to use the context here and the message itself. Okay, so let's wrap this function and return nil. Going to rerun our server. Okay, not enough arguments in call. Where is it? Okay, it needs a context here. Perfect. Okay. Let's check up on our servers. On user 2, we still have a message and we have no consumers for it. Okay, I'm going to connect as user 2. Okay. Client added. Aha. We forgot to call this function. Okay. Where is it? We can just call this here. Consume from message broker and then use the context background and the reference to the manager. Right here. So we have two Go routines per every client, one for direct messages when they are online and one for consuming messages from their queue when they were offline. Okay, everything seems to be good. Let's run this again. Connect to it again. Great, we have this message which has been sitting inside the queue forever, and if we look here, it should be empty now. Okay, that's it. We have actually done this. Adding the RabbitMQ here was a crucial step toward scaling out our project so that we can have multiple WebSocket servers running at the same time, because we want to handle high loads of user. And if you use just one WebSocket server, we are going to eventually run out of ports on the server. Actually, every WebSocket server can handle theoretically up to 65,000 etc. connections, simultaneous connections, but it's going to be much less than that because we are going to hit a resource problem before that. So this RabbitMQ here is actually the heart of our delivering messages. Okay, guys, I think this is enough for now. We have a working connection. We can connect multiple users to this one. Let's try again to see if we still have that direct message ability. Just needs to be a JSON. Okay, yeah, this is it. Let's take this user offline again, and I'm going to just going to try again. Target to message here. Let's copy this one. Our queue should be filling up quite nicely. Nope. Okay, this is an error here. WebSocket closed. Come on. This is an interesting error. Let's see what it is. Oops. Okay, I think what happens here is that whenever we try to write messages for an offline user, if the user was online before and then went offline, it's still going to have a reference here inside our manager, inside this client's map, because we didn't remove this from the manager. So it's going to try to write to the WebSocket and it's not there, and it's going to run into problems. One thing we can do here is right now, I think we're going to have to wait, find a way to detect if a user has disconnected from the server. Okay, let's check out this library here and see if there's anything for it. Okay, uninterrupt and shut down. Okay. Okay. Accept. Normal closure going away. Need to subscribe here. What does it do? Subscribe here just pins for the message, context on error, and okay, close read. I believe this is what we are looking for. Let's see what it is. Okay, we have this C. Close read. Close read start go return to read from the connection until it is closed or the data message is received. Once close read is called, you cannot read any messages. You cancel when the connection is closed. Okay, this is nice. Okay. So, let's try this one. We have a connection here and close read, which is going to accept the context. Okay, going to use background here, and it returns a context. And apart from that, okay, let's use this. If I have understood it correctly, this one's going to be cancelled whenever a user closes the connection. So here, stop consuming for ID here. Going to see if this is the one for it. Done listening for messages. Consuming CID messages. Let's add this one here. Cool. Here goes nothing. Yeah, it was actually nothing. This one is the correct one. Okay, going to connect and register. Okay, and just going to disconnect. See, okay, this is good. Done listening, stop consuming, and great. So, what was this? WebSocket closed. Failed to get reader. It's gotta be something here. Where is it that we are reading from the connection? Yeah, right now. Right here. Okay. I think this is where it's printing this error. Let's just add something. Failed to read from socket. Okay. Yep. This is where this error appears. I think it actually, because of the delay that we are having between receiving this context on and having multiple reads on this function here. So right now I don't have anything in mind on how to fix this, so I will be just ignoring that. The important thing here is that we detect if a user goes offline so that we can remove this from the manager. Okay. Let's do that. Okay. And where that happens is here. Okay. It's easy. Let's just first add this one. Func delete client context and a client and an error return nil and deleting, come on, from a map, I believe is just as easy as calling a delete on it. So it will be m manager. Yep. We have clients here and the type client ID. I believe this is it. So I'm going to do this here inside a go routine so that we don't block anything. And yeah, just like that, context done is our friend here. I'm going to manager delete client. Yep. This it. Okay. It's going to require context, and I'm going to pass it right here, the background. The client itself. Okay, and let's just print something. Client deleted. The client's ID. Okay, and on the server again. Let's connect. Register. Okay, and disconnect. Client deleted. Yep, this is it. We successfully deleted the client from the manager, so we don't end up with a broken WebSocket connection. Okay, I believe that's it, guys. If there's any connection, just there's any questions right now, just let me know and I will try to answer them. And if not, I'm going to call it a day. Okay, no questions 1, no questions 2, no questions 3. Okay guys, thanks for being here. If you managed to stick around up until now, and I know that this wasn't perfect, there was a lot of mistakes, and this isn't the best example of writing a project. It needs a lot of work to make it a proper one, but for the lack of time, I'm going to skip on that part, and I want to just show you how to create this WebSocket chat server. Okay, bye-bye, and have a great time.